Okay, so good morning, guys. It's Monday, May 11th. This is Physiology, and I just wanted to talk to you guys about the rest of the module for the nervous system and give you an update on where we are in terms of progress. Okay, so um, looking at our module, remember there's 5 folders. We've only been working on the first 2, and I went ahead and updated one little thing we're going to do on the assignments folder today. So we'll look at that in a second. But for those of you that want to go ahead and get a head start and just finish up this module, again, I'd like to make this a self-paced class, and the purpose of you guys attending these Zooms is so that you can ask me questions and I can really, fill in the missing pieces for the content, because I know that this is a lot of content. So I really want to give you as much support as possible. And then when you're ready, you can move on to the formative assessment, the discussion board, and the summative. So let's go ahead and look at the formative assessment. And so the formative assessment, like I was just saying at the beginning, is a quiz. And I believe I think I made it 13 questions. I already, let's see. Yeah, it's 13 questions. So if you're ready, please let me know. I will unlock it for you. So that's your formative assessment. I had put this Friday as the due date. I think once we finish up what I want to talk about today and Wednesday, you guys will be ready to take that quiz. But if you feel comfortable in taking it, you can take it today. So just as usual, just message me and I'll turn on the quiz for you. So that's the nervous system quiz. Your discussion board, I just uploaded today. So what we're going to look at today is a little video and give you some background info about concussions, which was the first little, hook that I started talking to you about to get you thinking about the nervous system and why it's so important. And so today we're going to watch a video about concussions, but let's go ahead and look at the discussion board. Can you read us this, please, Anna? Can you read us the assignment called Concussions?
After having read chapters 8 and 9, watched videos, read articles, and discussed the nervous system in Zoom groups, students will post L1, L2, and L3 questions they have about concussions and comment, react, debate, question, opinionate, discuss concerns they have about the brain trauma by responding to at least 2 other students with specific and cited evidence.
Okay, and as usual, here is your rubric for discussion boards, right? So I think you guys all know what I mean by L1, L2, and L3 because we've done this so much in class, and especially it's what we do during Socratic seminars. So Anna, can you tell us again, for those people that are watching this video, what is an L1 question again?
A question that the answer is straight in the article.
It's straight in the article, right? So if you look at the bottom, guys, I provided you 2 little websites, and one of them is an article that you're going to read from the CDC. That's the first one. It's about concussion, so it has very specific, and let's go ahead and look at it. So it has very specific things about what concussions are, how it affects, et cetera, et cetera. So that's one way that you can cite specific evidence, like Anna said, from the text. Can you tell us, please, Myrtle, what do I mean when I say an L2 question?
It's like your opinion, I guess.
It's not, it's kind of, it's something else though. Does anyone remember? Daisy, do you remember what L2 questions are, or you want to give another crack at it, Myrtle? It's not like your opinion per se. So L2 stands for level 2, Myrtle. Meaning it's not just the facts, right? It's something else. Do you remember?
Not really.
Not really? How about Daisy? Do you remember what I mean by L2 questions?
Is it when it relates to a text, but you also put some of your own knowledge in the question?
That, and it has to do with kind of like a major theme. So the video we're going to watch today, it's a 5-minute video on concussions, is going to be the follow-up to the first video we watched on concussions. And so like a theme would be something like Myrtle, right? You play volleyball. So you could, the theme could be like you said, kind of bringing your own opinion. And like Daisy said, you could connect that to, sports or you know what I mean? So it's digging a little deeper. That's what a level 2 means. How about an L3, Anna? Do you remember what L3 questions are?
Like, it's like a question that has an opinion-based question.
Yeah, so that's the truly opinion one. That's the one that kind of has to do with like yourself. Okay. So the first two, I do want very specific evidence, like Anna said. So you can pull evidence from this article I just sent you. And then I linked another one called Cracking Concussions from a website called brainfacts.org. And it's pretty cool. It's a video created by medical students where they use an egg to kind of represent what concussions do. And then one other thing that I linked to you guys is the regions of the brain. And let me go ahead and show you that. I think I forgot to link it. So let me go back. I'm going to move this link. Okay, let me just show you something. So in your websites, I didn't correctly link it, but I'll move it now. Okay, so I put this thing called the 3D brain. And if you click on this, it shows you the brain in 3D as well as the major structures of the brain. It's pretty cool. And again, if we were in class, we'd be using our iPads together and we'd be, looking at different parts of the brain and, zooming in, zooming out. But since we're not in class and we don't have the ability to share iPads, this website is like the second best thing I could find. So what you do is you scroll down and you pick a region. So let's say we're looking at the frontal lobe, okay? Notice you can actually move this, right? So it's animated. So if we're looking at the frontal lobe, for example, and you want to know, well, where is the region of my frontal lobe that's responsible for motor or for movement? So you click on the premotor cortex, for example, and it highlights it there for you, okay? So I'm going to link this to the assignment called Concussions. So my bad, those people that are watching this video. I forgot to link that one. So for the specific evidence, I will make sure that that is included here in the discussion board assignment. So again, we're looking at the discussion board and I accidentally forgot to link that website. So one of the specific evidence you could link from that website that I just showed you, which is this one here, could be like if a concussion occurs like in this part of the brain, a question that Anna could ask about, the opinion could be like, well, if I got a concussion here, what would happen to the brain or my body as a result, right? And you could cite from this website. So I'll make sure that I include this website along with this discussion board, which I forgot to do. So my bad, I'll do it as soon as this class ends. And then again, don't forget that you have to comment on at least 2 other students as usual, right? You always have to comment and talk to other people. So any questions, guys, about the discussion board called Concussions?
No.
You guys are good? Okay, cool. So that's the discussion board. So I already showed you the quiz. I just showed you the discussion board. And then it's awesome how many people turned in really cool projects for the endocrine system. So most people did like PowerPoints, but they have like narration and talking. I'm fine with that. Like I said, these summative assessments are really just meant to be kind of like a DC frame, but beefed up, right? So I thought it was really cool, and I think we had a discussion last time and people said that they were okay with that. So we'll do the same thing for the nervous system. We'll wrap up with another little video project. So if you could please, how about Myrtle, could you read us the instructions for the summative assessment called Pathology of the Nervous System?
Students will work in groups of 2 to 3 or independently to explore, explain, and elaborate to any of the following pathologies of the nervous system and evaluate their causes and treatments in a brief 5 to 10 minute video or 10 to 15 slide digital presentation.
And like usual, here is your rubric. Notice one student already did it. And that's the cool thing about this is that you can do this whenever you want. So the pathologies of the nervous system, I'll just go ahead and show you that now, just in case people want to get a head start, like one student already did. These are the pathologies. And so these are the ones that are mentioned throughout chapter 8 and chapter 9. Let's go ahead and look at them. Let's read them, please. And then I'll show you where in the book you can find this stuff. So can you read us, please, the first 4? How about Daisy?
Alzheimer's disease, Parkinson's, Bell's palsy, and cerebral palsy.
Can you read us the next four, Anna?
Epilepsy,
Epilepsy,
epilepsy, dementia,
dementia,
multiple
sclerosis.
sclerosis. Wait.
We just call it MS. You can just read the
Okay.
parentheses if you want. Yeah.
MS and ALS.
And ALS.
Yeah.
ALS. I know you guys have heard of it.
Sorry.
And it's okay, Anna. I know you guys have heard of it. Do you guys remember the ice bucket challenge from a couple years ago?
Yes.
Right, when the world was normal, people were doing that challenge where they would pour freezing cold water on themselves just to kind of simulate what it's like to have ALS, also known as Lou Gehrig's disease. So all this is found in the end of chapter 8 and chapter 9. So if you want to look at some of these, that's fine. However, I've really been pushing for concussions. And so I'm going to show you and talk a little bit more about concussions. And then I'll also talk to you about strokes. So strokes are basically like a heart attack, but in the brain, because you have blood vessels on the brain. And so if you choose to do stroke or concussions, which is what I'm talking about today, notice that I'm saying you have to discuss a section of the brain. So you can't just say strokes in general, because that's really easy, or concussions in general. That's really easy. We've been talking about that, and we're going to do that in the discussion board. So if you want to choose concussions and you want to focus on, for example, like the cerebellum or the frontal cortex or some specific region of the brain, that must be part of your discussion for concussion. So you would say, like, if there was a concussion in this part of the brain, this is specifically what would happen. And you would show us, videos or diagrams, or you can even, if you're down for it, you can show us the old school ice bucket challenge and make some kind of cool project on it. So as usual, it's limited by your creativity. Okay, so like Myrtle just told us, and I'll go back to the slide. Hold on, sorry guys. I'll go back to Schoology. So like Myrtle just told us, like last time, you can do a 5-minute video or you can do a digital presentation. It's totally up to you. So any questions about the summative assessment?
No.
No? Okay, all right. So, so let's go back and finish up this module. So where we left off last time, we were looking at the notes. And we were looking at neurotransmitters. Okay, so that's where we left off. And again, my notes are found here, but I like to go full screen. So I'm going to open up another one here. So this is my rest of the notes for the nervous system. So where we left off, we were talking about this flow chart of the nervous system. And we were talking about, what would happen if I were to step on a nail, what were to happen if I were to poke myself, and how the different systems of the nervous system, like the CNS and the PNS, work together to send messages back and forth to us so that our bodies can react and essentially stay in homeostasis, right? Because homeostasis, is kind of like the bread and butter of anatomy and physiology. Remember, it means balance. So even the nervous system is responsible for keeping us in balance. For example, if we look at the sympathetic nervous system versus the parasympathetic, the fight or flight response is a great example of that. So let's say that Trujillo is trapped in a burning fire or some terrible accident. I don't want to die. So my sympathetic nervous system, which is part of the autonomic nervous system, kicks in. And so we talked about neurotransmitters last time, and I showed you this. And I told you that if my nervous system wants to communicate with other neighboring neurons so that I can then respond to the threat, my neurons, which we call the presynaptic neuron, would send a message, and I'll go ahead and draw again for you in red. So my presynaptic neuron would send a message we call a neurotransmitter, which is essentially just an electrical signal, which we call an action potential. It would send a signal from the soma, or the body of the neuron, down the axons via this little insulating barrier we call the myelin sheath. It would travel down the axon terminals through all of its terminals, and the number of terminals varies, but it would travel down the terminals to the end where we have these little pockets we call vesicles. And those vesicles release into a gap or a cleft we call the synapse. It releases that vesicle, which is where the neurotransmitters are housed, and it releases it into the neighboring neuron, which we call the postsynaptic neuron. Okay, so this is a very simple representation of how a neurotransmitter, in the case of adrenaline, for example, let me go back. So I gave you guys a list last time of neurotransmitters, and we have said a neurotransmitter that you're familiar with is adrenaline, right? So in the case of me being trapped in a burning fire or something like that, my nervous system, specifically my autonomic nervous system's sympathetic nervous system, would kick in so that I can act or respond to the danger, right? So we call that the fight or flight response. So the neurotransmitter called adrenaline and or epinephrine, adrenaline is just like its colloquial name, epinephrine, norepinephrine would kick in. Even cortisol. Cortisol is something that increases metabolism in our bodies so that we can respond. It would kick in, and in that fight or flight response, that sympathetic nervous system would cause an increase of those neurotransmitters so that I can act, okay? The opposite reaction of the sympathetic nervous system is what we call the parasympathetic, right? Because I don't always want to be all amped up on adrenaline. But why not? What's bad about that? We talked about this last time. Why don't we want to be amped up on adrenaline all the time?
Because it makes your heart race.
Yeah, it makes your heart beat really fast. It makes your lungs beat really fast. On average, guys, your heartbeat is going to beat about 2 billion times in your lifetime. If you do the math, that's about 70-ish years. Some people go like 3 billion beats in a lifetime. That's, 100 plus age. So think about it, right? Like Daisy said, if you have your heart beating all the time, you're running out of beats. That's not a good thing. You don't want your heart beating all the time. It also increases your heart rate, your breathing rate, and your digestion. So you don't want to be that all the time. So the opposite reaction to that is called the parasympathetic, which is the rest, right? So it's what lowers the level of those hormones and neurotransmitters. So that's a good example of how homeostasis is maintained, right? Because homeostasis means balance. We don't always want to be amped up. We need to have the opposite reaction. So that takes care of the nervous system. Now I want to talk specifically about the brain and the spinal cord. Spinal cord is pretty easy. I don't need to say much other than it's the long, stringy bundle of nerves that we call a ganglion, found in the middle of our vertebral column. And what it does is it communicates the brain's commands throughout the body. So at the beginning of this module, I showed you guys this picture. So here is the brain, and that's the spinal cord. And I'm not saying the spinal cord isn't important. It's obviously incredibly important because, like we know from paralysis, people that have had injury to the brain, or the spinal cord, I should say, if you damage a vertebra and break the spinal cord, depending on where it is, you would lose function of the rest of the nerves, depending on where you broke it. So obviously the spinal cord is very important, but what I want to talk about today is the brain. So in the book, it talks about these 3 different brain developmental areas, meaning this is how your brain starts, but it's not what we refer to in adulthood anymore. This is kind of just like the way it starts, and then as you become an adult, we traditionally divide the brain into these 4 regions called the cerebrum, the diencephalon, the brainstem, and the cerebellum. And I put in parentheses here so you can kind of see like what that used to be. So the forebrain in development, it starts as that, but then as you become an adult, it matures into what we refer to as the cerebrum, which I'll show you. The diencephalon is also part of the forebrain area. It's what we, it's beneath the cerebrum, and I'll show you a picture of that as well. The midbrain is what we refer to as the brainstem in adulthood. And the cerebellum is kind of the back part of your brain, or the posterior. And so we call it the hindbrain. And so what I'm going to do is just show you guys a picture of all of these, and then we'll discuss it a little further on Wednesday. Okay, so here's a picture of your cerebrum. Okay, so when you think of the brain traditionally, this is what you're actually talking about. You're talking about the cerebrum. So the cerebrum is kind of like the outer gray, and we call it gray matter. It's the outer layer of the brain that has all these little wrinkles on it, which we call gyri. Okay, and it also has not just wrinkles, but actually really, really deep grooves in it that we call the sulcus, which we'll be looking at very soon. So that's the cerebrum. And the cerebrum is divided into more specific areas and so the cerebral cortex is what we kind of call like the divisions of it. And the cerebral cortex itself is also divided into lobes, which we'll be talking about this week. Okay, so these are some of the lobes you're probably familiar with. And the cool thing about the brain anatomy is that it kind of has the same names as the cranium. So frontal bone, well, that's where the frontal lobe is located. You guys may remember the parietal bone of the skull or the cranium. Well, that's where the parietal lobe is housed. Same thing here. Temporal lobe is where the temporal bone of the skull is located. So that's right there. And the occipital lobe. So we'll be looking at this a little bit more in class this week. Okay, so that's the cerebrum and its subdivisions. The diencephalon, like I said, is what used to be referred to as the forebrain when you were developing, but in adulthood, the diencephalon refers to the hypothalamus, the thalamus, and even a region. It's right by the pituitary, but it's mostly the middle part of your brain. Have you guys ever heard of the limbic system? It's something that
No.
you haven't heard of it. Okay, so the limbic system is something that I thought maybe you guys had heard of. It's kind of outdated. No one really talks about it anymore. But I pulled this up on Pinterest because it's not found in our textbook because it's not really used anymore. But back in the 60s, when people were still kind of studying the brain, this old neuroscientist came up with what he referred to as the triune brain theory. Don't worry about this. This won't be on the quiz, but it's interesting. And he said that our brain actually is divided into 3 regions, which he referred to as the lizard brain. You see why this isn't in our textbook? The mammal brain and the human brain. And that sounds really weird, but let me tell you what he meant by that and why we no longer accept this theory anymore. The lizard brain kind of refers to the regions of the brainstem and the cerebellum, which he said is kind of like the primitive brain, which any animal can do, including reptiles and lizards. So he kind of coined the term lizard brain or reptilian brain, meaning that all reptiles, basically things that aren't mammals, have that region of the brain, and that is true. They have the basics of a brain. But what they don't have, what a reptile, what a snake does not have, and the reason they can't do calculus and write symphonies is because they don't have the more advanced regions of the brain that you do. Okay, so in this old school theory, the limbic system referred to the region of your brain where emotions, anger, sexuality were believed to be housed. Now we know it's a little more complicated than that. And then in the human brain, which again, a reptile doesn't have, but neither does an octopus, they don't have the outer regions of the brain, which he referred to as the neocortex. And that's kind of where I'm going to stop talking about this because this is kind of outdated. We don't talk about the brain like that anymore. We know it's more complicated than that. But in that old way of thinking, that would have been the diencephalon. That would have been what he called the reptilian brain, because we'll talk about what it does and why almost any animal can do that, right? So that's why he called it the primitive or the reptilian brain. But anyway, enough about that. We're talking about brain anatomy as we understand it now. Then we have the brain stem. The brain stem is basically what it sounds like. It's the bottom part of the brain. So that includes the midbrain, the pons, and the medulla, or the medulla oblongata, one of my favorite words to say, which we'll be looking at this week. And then lastly, the fourth part of your brain is what we refer to as the cerebellum, which basically means a little brain. And it's because it looks like a small miniature brain at the base of your cerebrum. So we'll be looking at these four parts of the brain this week. So once we finish today's class, just please go ahead and look at that website I provided you on the 3D brain, because it shows you some really cool animations of the brain, which I can't show you on my PowerPoint, obviously, okay? So let's go ahead and just briefly introduce the brain here. And then, like I said, this week, I'll give you more background on it, okay? But for now, the focus is gonna be the brain and brain trauma. Okay, that's what I wanted to talk about today. So just please note that as adults, these are the regions of the brain that you have. During development, you had these three regions, but again, they develop, as you can see, further into more specific regions known as the cerebrum, the diencephalon, the brainstem, and the cerebellum. So again, I'll talk more about that on Wednesday, but what I wanted to do today, like I said, was show you a video about concussions and then think about how a concussion could affect a region of the brain. Okay, so let me go back to Schoology so you guys can see where that video is, and we're gonna watch it together. It's a short little video. And get rid of this little Pinterest thing. Okay, so let's go back to the nervous system module. And so I included a little video that I want us to watch today on concussions in the brain. And I know, Myrtle, you play volleyball. Daisy or Anna, do you guys play? Anna, you play sports, right? Tennis?
Yeah.
Okay. Not too many concussions probably in tennis, but Myrtle, I can imagine, right? Because people fall, spiking, right? So lots of dangers. But in tennis, Anna, are there many injuries? Like with the brain, probably not, right?
No, I don't think so.
Unless someone
You get hit with the ball.
With the ball, right? So
yeah, just one time on the stomach. That's it. I got hit.
oh, really? Okay, so let's watch this short little video, and then I have some little discussion questions that we'll watch. Okay, so let me go ahead and turn on the video. Let me know if you can hear this, guys, with the thumbs up. Let's see. Okay. So give me thumbs up if you can hear this, okay?
Reed Snyderman is 17.
Okay. I'll go full
A high
screen.
school junior, he plays varsity lacrosse, and he's the U.S. Junior Olympic champion in freestyle skiing. It was the last day of spring break in 2008 when his trouble started.
I was at U.S. Nationals, and I ended up just kind of catching my edge and kind of flipping and hitting my head. And then being really bewildered and not really knowing what was going on.
His coach went over to him first and came back to me and said that he thought he was fine, except he might have a mild concussion.
But Reed was not fine at all.
I was really out of it. It was really difficult for my brain to maintain a train of thought. It was definitely scary.
Almost 4 million athletes, boys and girls, suffer concussions every year. Many of them recover quickly, and a bang on the head is often considered just part of the game. You shake it off and get back to the field as soon as possible. But for 20% of patients diagnosed with a concussion, recovery isn't so easy. Because even when it's mild, a concussion is a traumatic brain injury.
If you look at traumatic brain injury, it is the #1 cause of death and disability in young people.
Jam Kajar is a neurosurgeon at Weill Cornell Medical College in New York and an international expert in brain injuries.
90% of traumatic brain injury is concussion. And how many numbers are we talking about? There are millions.
But concussions are difficult to diagnose. they generally don't show up on a standard MRI. MRIs produce images of gray matter, cells called neurons and their connections, which make up most of the surface of the brain. But a concussion doesn't usually do much damage to the gray matter. So now, neurologists are searching for clues deeper within the brain, in the white matter.
The white matter makes up the sort of cables or connections between the lobes or the sections of the brain.
Gajar's theory is that microscopic tears in the white matter disrupt communication between different parts of the brain responsible for helping us to pay attention and remember what's going on around us.
There are populations of cells that communicate with each other and produce brain function. If you disrupt the connections between these areas, you disrupt attention and memory.
And please.
To test this idea, I'm participating in an experiment Gajar devised to measure a person's ability to pay attention. This device records how well my eyes stay in sync with a moving target. So these cameras are watching where my eyes are moving.
Yes.
We picked eye movements in terms of following a predictable target. And you can't drive your eyes in a circle automatically. You have to pay attention to the target when it's going around.
For most people, this test is easy. My eyes follow the target with no break in the cycle. But for someone who has symptoms after a concussion, it's a different story.
A head injury patient is just wobbly all over, constantly having to start over again.
And one scary thought is sending a student who's had a concussion back into the game. This can happen because there's no way to objectively diagnose concussions on the sidelines, and young athletes most often don't want to be benched. But what if there were a tool to quickly and accurately assess if a brain injury has taken place? That's Jam Gajar's next goal.
You can see this.
He's developing a small portable version of the eye tracking system I tried in the lab. The same moving circle is projected directly onto the lens of the specially designed pair of glasses. Then a miniature camera records how well the eyes follow it. It's a quick way to tell if a concussion has taken place, impairing the brain's ability to pay attention to what's happening on the field.
Let's go, let's go!
And that's an essential piece of information, because an athlete who's had one concussion is at high risk for another.
The person who's got poor attention, you don't want to send them back into play. Send them back in, they are unable to pay attention, and they get another injury. You keep on adding those concussions together, then you see things like dementia and so on, later in life.
6 weeks after his concussion, Reed has made a full recovery. But the experience stays with him every time he heads onto the field or the slopes.
I think a concussion is one of the scariest injuries that you can get. Like, I mean, when you break your arm, you're still you still can think, you still can, you can function fine, but when you hurt your brain, even when it's minor, even when it's not major, it's like you're not you for a while. And that's definitely frightening.
Okay, so go ahead and stop the video there. And let's talk about this. So I posted a little worksheet here for us to discuss brain trauma. And again, this will be part of your discussion board, which is why we watched that video and why I posted the article for you to read on concussions. So let's go ahead and have a brief conversation about this. So like I said, Myrtle, for sure, you're at risk for this. All athletes, I mean, not even just athletes. You can get a concussion while driving. You can get a concussion just, walking down the street and you trip and bang your head. So it's not specific to athletes. The reason I chose this video was because I know we have a lot of athletes at our school. So we're not doing this as a breakout group, obviously not enough people, but let's just go ahead and talk about it. So can you read us the first question, Anna?
What is the #1 cause of death and disability in young people?
So that's a no-brainer. What was it?
Concussion?
Yeah, concussions, right? Bad joke, sorry. So what is a concussion, guys, in your own words?
It's a brain injury.
Yeah, it's a brain injury, but caused specifically by what?
like when you hit your head or something.
Yeah, it can, like I said, it can result from many different ways. The third question, can you read us this one, Daisy?
Why does suffering from one concussion increase the chances of having another concussion?
What do you think?
Because like once it happens, like you already have like damage. So if you get hit again, like you just have a higher chance of damaging your brain even more.
And the thing with the concussions, like they were saying, is they're very difficult to diagnose. We don't have like the technology. I mean, like an MRI is one thing, and actually, let me show you guys something. MRIs are great, but they're kind of limited. So let me show you guys. I had a picture of an MRI in here somewhere. Check this out. In your website folder, I just put this for fun. Especially Myrtle, I know you're medical school bound, so you're definitely going to be doing MRIs. So I posted this thing called Mapping the Brain, which is pretty cool. Just, you know, to extend your learning, not a requirement. But what MRIs do, it stands for magnetic resonance imaging. What an MRI does is they put you in a machine and they scan your brain. And so it can scan it a couple different ways. So at the beginning of class last, I think this was in August, September, we talked about the different hemispheres of our body. And we talked about the terms coronal, sagittal, and specifically the different directions that you can cross-cut, right? So if we do a coronal MRI, which you can see here, and we get basically an out to in view of the brain, which is really cool. So if I want to look at, for example, the cerebellum, okay, you can go ahead and click on cerebellum here, and you can see in a coronal view how the cerebellum looks. So they do MRIs to look at the brain, but unfortunately, the MRIs don't always capture the damage, like they said in the video, because the damage occurs a little bit deeper. And so MRIs kind of just capture like the surface. They don't even show activity necessarily. They're just kind of just like pictures, basically, of the brain. So that's one cool tool we have, but it's kind of limited. Okay. So the next question, can you read us, please? How about Anna, since you're an athlete? Can you read us that fourth one?
We learn here that it is difficult to diagnose a concussion from the sidelines. How would you advise a coach if one of his or her players received a blow to the head? What do you think about a coach saying to a player who has hit his or her head, shake it off and get back on the field?
So what do you think?
I don't think that's a good idea because it could cause like long-term damage.
And like they mentioned in the video, they call them TBIs, traumatic brain injuries, are the leading cause of death for young people. So this is something, you know, for athletes. That's why I picked this video. Myrtle and Anna, I know you guys play sports. But again, anyone, even me, I don't play sports, but we're all at risk. Just, you know, driving a car, skateboarding. So just be aware, okay? And they talked about eye movements, but I'll go ahead and skip that last question. There's not enough of us here today, but it's okay. So anyway, that's the video. Here is the URL if you want to rewatch it. And again, you can use some of this information for your discussion board, but specifically the discussion board assignment, like we said, your L1, L2, L3 questions, you do need to include evidence. So you could cite evidence from this video or from the other links that I posted for the discussion board. Okay, so that is the concussion stuff that I wanted to talk about. And what we'll do on Wednesday, like I said, is we'll continue talking about the different, we'll look at the 4 regions of the brain, and we'll use that MRI page to kind of highlight the different regions of the brain, and then we'll talk about concussions. So like if there is a concussion or some other brain injury in, for example, the cerebellum, we're going to talk about, well, what would that do? How do we know that the cerebellum actually controls what we say it does? Like, how can you prove that? Okay. So unfortunately, injury shows us brain function, because before we had MRIs, before we had ways to scan the brain, we didn't really know what the brain does. I mean, if you've never looked at a human brain from the inside, hopefully you will soon in college, right, Myrtle? It's there's no instructions on a brain, there's no wiring on a brain, there's no labels on the brain. And so the way that we learned about brain function is actually through brain trauma. When people damage a certain part of their brain and they lose function, like for example, someone has a stroke, and like the temporal lobe, which is where speech is controlled. If that part of the brain gets injured, which we'll talk about on Wednesday, in the cerebrum, we'll talk about this Wednesday, they lose function of certain aspects of speech, which is very, very interesting. And again, we wouldn't know this if injury hadn't occurred. So there's a lot we can learn about the brain through trauma. And so we'll talk a little bit more about trauma, or TBIs, traumatic brain injuries. And again, that'll be a part of your discussion board. But like I said at the beginning of class, the quiz is ready to go. The quiz will end with the last 4 sections of the brain. So if you just want to get a head start and read ahead of me before I talk about these 4 last parts in my notes, you can go ahead and read it today if you want, and then you can message me and I'll turn on the quiz for you. But if not, you can wait, and I'll be done with all this by Friday, so you can take your quiz on Friday. Okay? Any questions so far, guys, about anything we've talked about?
No.
No? You guys good? Okay. Yeah, so I got an email also, not just about the yearbook stuff, guys, but about scholarships. Myrtle and Daisy, Miss Soldavia told me to talk to seniors. Did you guys know that there are lots of scholarships available for you guys?
Yeah, I saw it.
Okay, so you already took advantage. How about you, Daisy?
Yeah, me too.
You do? Okay, okay. So you guys don't need me to forward you any of these applications?
No.
Okay, okay.
No.
Okay, just checking in. And Anna, that'll be you next year. Okay. All right, guys. So I'll go ahead and end early. It's 11:22. But I don't want to go any further because the regions of the brain, it's a lot. So we'll talk about that on Wednesday, and we'll look at MRIs and different brain imaging so we can understand the brain a little bit better. Okay. So if no other questions, guys, I'll see you on Wednesday.
Bye.
Okay. Bye, guys. Thank you.